Hey, this is Doctr Night Class. Go ahead and click like and subscribe below. Hope you enjoy the medical content. Weapon of choice is laser pointer. This is MSK, Muscular Skeletal System. We're going to start with physiology, and then a tiny smidget, 2 slides of reflexes, okay? That's basically it. On Friday, we'll continue with upper limb, okay? There's a lot of points in the upper limb. We talk about brachial plexus. However, there's a lot of points in muscle physiology, a lot of points. You have to know the story, guys. It's a story. Remember that story we talked about? How something leaves the nucleus like an mRNA, and it's mature, and it gets to the ribosome, does translation, and after that, it gets folded by a chaperone, and then it gets post-translationally modified, and then it gets on the COP2 system and the microtubules. It's a story. Muscle physiology, it's a story all over again. If you know the story, let them take their best shot. Doesn't matter what question they ask you. Once you know the story and how it's supposed to be, it's easy to pick out when there's a question. It's easy to pick out what's wrong with the question, what's right with the question. Okay, so we have to talk about the story, guys. So here's the story. All right, this is one of those big picture, looking at the big picture, right? There's a lot going on the slide, a lot. This concept sheet is more busy than what I usually put up here. However, this is a big picture scheme. I want you to see the big picture. And kindly, in night class, we integrate as we go. So, are you surprised to see this guy here? Are you surprised to see this diagram here? Maybe the hot dog with the bun? Yes, right? Right? You shouldn't be surprised because we integrate as we go. Okay? We have Wreck-It Ralph here. This is new. We're going to talk about him. And then we have our telephone for signal transduction, right? The ligands, it made it to Cas2. Okay, so I said once upon a time, medicine, the academia of medicine, if you see something that's repeated over and over, like it's mentioned once in week 1, it's mentioned again in week 3, it's mentioned again in week 5, that is, it's important. It's important. If it shows up multiple times, it's important, right? All right, so let's begin this. A stimulus from the neuron. This is where we're starting. And basically, we're going to excite some skeletal muscle. Okay? There's going to be a lot of sequences of events, but ultimately, we want a contraction. We want the skeletal muscle to contract. And we mentioned there was 3 types of muscles, right? We sure did when we talked about histology a little bit. Okay? There are 3 types. We're just talking about skeletal muscle here. So we could begin here with our neuron. Okay, we mentioned that there was a cell body of the neuron. This is where that neurotransmitter is actually made, right here in the cell body. Okay, now if we had our lens, our vision of integrating this to like week 2 foundations, right? Week 2, we could say that this cell body could be very similar to the nucleus. We could say that. We could say that. This cell body somehow has to come up with a protein. It has to post-translationally modify it, right? Because we learned that neurotransmitters, they're basically proteins that have been post-translationally modified. We talked about that, right? Didn't we? We said all a neurotransmitter was a protein that was post-translationally modified. Was it hydroxylated? Was it glycosylated? Right? That's how we mentioned them, right? So all of that happens with this system here. Okay? Again, it's going to use the COP2 system to travel. So we made a neurotransmitter here. The COP2 system, sure, it can go down the axon. Why not? We've made a neurotransmitter, it's in the vesicle, goes down the axon through the microtubule system. COP2 means peace out, right? Peace out, COP2, exocytosis. You're being kicked out. The bar is closed. You don't have to go home, but you need to get out of here, right? You're kicked out. Kinesin, right? And then at the 4.5-week lecture, we mentioned that there's one more step here. There's an influx of calcium, which helps this vesicle that has the neurotransmitter, it helps it leave the presynaptic cleft, right? Even further back with integration, we talked a little bit about an axon, and we said the speed of conductance, the speed of the signal of the message is dependent on something. How big this axon is, how big this fiber is, right? And we said, we compared it to a hot dog. A hot dog is, if it doesn't have a bun, the hot dog isn't as big, right? But if it has a bun, the hot dog's big. What am I trying to say, guys? I'm trying to say if an axon has myelin around it, the more myelin it has around it, the bigger it is, the faster the transmission goes, the faster the conductance, the faster the signal goes down there, right? Okay, so we integrate as we go in night class. We know this, right? We know this. Now, we know our story, how it reflects into week 2. We do, okay? Now we have this neurotransmitter. We have this neurotransmitter released at the presynaptic cleft, and it's hanging out between the presynaptic cleft and the postsynaptic cleft, okay? Now, guys, this neurotransmitter, we're going to give it a different name because it's a different neurotransmitter. I introduced 2 neurotransmitters, 2 main ones, and this was specifically in the brain. This was glutamate, and this was GABA, okay? But at the site of the neuromuscular junction, the skeletal muscle postsynaptic cleft, at the site here, we're not using glutamate, we use acetylcholine. It's just a different neurotransmitter. It's equivalent to glutamate. It also is excitatory. If it's excitatory, what can I expect? I can expect sodium going down its concentration gradient, or maybe even calcium, okay, to depolarize the inside of the cell. Depolarize the inside of the cell. When I say depolarize, I mean inside of the cell is becoming more positive, okay? It's an influx down its concentration gradient. So we know this story here. What do we have here? This is an edit to our story. We just added one thing here, just one thing. We know all of this story already. So who is this? Well, if Fix-It Felix is here making neurotransmitters, he's got his hammer, he's ready to make stuff, right? This is Wreck-It Ralph. This is Wreck-It Ralph. Does anybody like kids' movies? I like kids' movies. Anybody like kids' movies? Anybody know this movie, Wreck-It Ralph?
I definitely know this movie. I love it.
Well, Wreck-It Ralph, his character, he's responsible for breaking things down. He wrecks things, okay? We're going to call Wreck-It Ralph acetylcholine esterase. And what acetylcholine esterase does, it breaks down acetylcholine because we cannot leave acetylcholine just floating around here. If it just floats around, it'll constantly be stimulating this depolarization. Constantly. It'll do it once, it'll do it twice, it'll do it thrice, it'll do it twice. It'll keep doing it over and over and over, and your muscles will fatigue. Your muscles will fatigue. It's too much. This acetylcholine esterase, very important. Very important. We only want one stimulation, one depolarization. We can't have it keep going over and over and over, okay? So this is going to break this down. After acetylcholine touches its ligand receptor, which is called, a new term for us, nicotinic receptor. A nicotinic receptor is the receptor that's on the postsynaptic cleft of the skeletal muscle. You will find it nowhere else. It's only on the skeletal muscle. Okay? Now there are some analogous or very similar receptors on the postsynaptic cleft. Similar ones like a muscarinic receptor, but that's on a different type of muscle cell. That's more on the cardiac muscle cell or the smooth muscle cell. Today's lecture, we're talking skeletal muscle, so you can just lock in the nicotinic receptor for skeletal muscle. Okay, we'll save those muscarinic receptors for another day.
Dr. Florenstein.
Mhm.
Yes, sir. I'm just wanting to confirm by the picture of the telephone being here that this is a water-loving molecule and it needs a secondary messenger.
Yes, exactly. It is, because it's a protein, right? It's a protein which has charge on it. It's a polar molecule. Polar molecules cannot go through the plasma membrane at the postsynaptic cleft. What's going on here? This acetylcholine is stimulating this receptor here. Okay, there's going to be a second messenger system. The second messenger is going to recruit receptors to the plasma membrane, going to recruit receptors here so that these ion channels can open, and then these electrolytes like sodium and calcium, they can move down their concentration gradient and do a really, really nice depolarization dance. Really, really nice. And we're going to tie that into how it stimulates muscle. Okay, so this is a big scheme picture. I want you to know the story. If you know the story, you're ready, you're academically competitive, you go to the exam, go get some points. Okay?
For more night class content, go ahead and email me at doctrnightclass@gmail.com. That's DOCTR nightclass, gmail.com. Hope you enjoy the content.